The problem is to solve the system of equations where x plus y equals 100 and x times y equals 100. We start by isolating y in the first equation to express y in terms of x. We substitute the expression for y into the second equation to have one equation with one variable. This substitution gives the equation x times quantity 100 minus x equals 100. We'd expand the left side to get 100 times x minus x squared equals 100. We rearrange the equation to set it equal to 0 by subtracting 100 from both sides. We multiply the entire equation by -1 to make the quadratic term positive. We apply the quadratic formula to solve for x in the equation x squared minus 100x plus 100 equals 0. We identify the coefficients a equals 1, b equals -100, and c equals 100. We substitute these values into the quadratic formula expression. We simplify inside the square root by calculating b squared minus 4 times a times c. We rewrite the expression for x as 100 plus or minus the square root of 9,600, all divided by 2. We simplify the square root of 9,600 by factoring it into 10 times the square root of 96, then further to 40 times the square root of 6. We rewrite x as 100 plus or minus 40 times the square root of 6, all divided by 2. We divide both terms in the numerator by 2 to get 50 plus or minus 20 times the square root of 6. We find y by substituting x back into y equals 100 minus x, resulting in 50 minus or plus 20 times the square root of 6. The solutions for x and y are the pairs 50 plus 20 times the square root of 6 and 50 minus 20 times the square root of 6, or vice versa. We begin with the system x plus y equals 100 and xy equals 100. The first equation is a line, shown in cyan. The second equation is a hyperbola, shown in orange. Their two intersection points give the two ordered pairs that satisfy both equations. The quadratic roots produce the exact coordinates shown.